We'll be looking at more example on dimensional analysis. There's a problem here. A wave is set up in a stretched string by plucking it. The velocity v of the wave depends on tension T in the string, its length L, and its mass m. And this v is equal to kt raised to power x, L raised to power y, m raised to power x, where x, y, z are unknown and k is equal to 1. Derive an expression using v, t, l, and m. It is simple. We are presented with 4 parameters here. V is equal to, remember k is 1. The constant is 1. So we ignore it, and t raised to power x, L raised to power y, and m raised to power z. So we ask this velocity, this tension, another name for tension is force. This is length, this is mass. So we simply insert the dimensions of these parameters. And we know that the dimension of velocity is L t raised to power minus 1 equal to force. Remember, we said that force is mass times acceleration. The dimension of mass is m. Acceleration is Lt raised to power minus 2. So the dimension of tension, which is force, is m L t raised to power minus 2 raised to power x. And L is y, dimension is L, m is z. So it becomes simple. So we open the bracket, we have Lt raised to power minus 1 equal to x multiplied by m is m raised to power x. X multiplied by L is L raised to power x. X multiplied by t raised to power 2 is t raised to power minus 2x. And then we'll have our L raised to power y and m raised to power z. So we'll now collect like terms. Collect like terms. So we have L t raised to power minus 1. We bring the m's together. So we have m raised to power x plus z according to indices. We bring the l's together. That is L x plus y, and t is t raised to power minus 2z. So this is the left hand side of the equation, and this is the right hand side of the equation. Whatever you do to the left hand side, you must do to the right hand side. So we equate the powers. Equating the powers, we now have, let's start for t. T on the left hand side is t raised to power minus 1. On the right hand side is t raised to power minus 2x. Minus 2x. So it means that minus 1 is equal to minus 2x. And this implies that x is equal to half. So we have determined what is x. So for L on the left hand side, we have L raised to power 1, and on the left hand side we have L raised to power x plus y. So this becomes 1 equal to x plus y. Already we have determined what is x. This is equal to half plus y. So if we take this to that side, become minus, I will have 1 minus half is equal to y. I can say that y is equal to half. We have determined what is x and y. So we'll move to the last one. On the left hand side, that is for m, we don't have anything on the left hand side. For the right hand side, we have m raised to power x plus z. So we can write this as 0 equal to x plus z. Already we have determined what is x as half. So 0 is equal to half plus z. So by the time you take this to the other side, it becomes minus. So you can say that z is equal to minus half. Therefore, x is equal to half, y is equal to half, z is equal to minus half. So we'll come back to the original equation, which is this. Therefore, v is equal to t, x is half, that is t raised to power half, L, y is half, that is L raised to power half, and m raised to power z, z is minus half. So we can write this as v is equal to square root of t L all over square root of m. So we can say that v is equal to k square root of tl all over m. So this is the expression as relating v, t, l, and m.